So I have to start with the question number 9. So that is numerical problem. So there are 4 numerical problem. So I'm going to discuss the 4 numerical problem over here, right? So I'm starting with the question 9. But before starting, I just want to tell one thing over here, that if you look at the question number 9 itself, it is one of the toughest question which they have asked in maths paper 1, correct? So in exam, if I were a student, I will be giving this paper, I would not have attempted this question at all. Why so? Because looking at the question itself, it is difficult, right? Now, if it is difficult, so we need to move on. Our mind will tell, no, I should attempt that. We have studied equivalence relation, we have studied about the partition also. So our mind will keep telling that we have to solve this question. But again, my suggestion, even if we'll start solving this question and you will give 1 minute to that question, what you will realize that you're not going anywhere. So better to leave that question and move to the next question. Next question is a better question and you should move, right? But I am telling you why I'm suggesting you not to solve this question during the exam, right? So what it is there, now if you observe what basically it is there, so there is a set S. So there is a set S which contain 10 element over here, and I am interested in how many element present in this X, right? And what does this X contain? It contain R such that this R is an equivalence relation. Till that point, no problem over here, but they are putting an extra condition over there. Now, what is that extra condition over there? Equivalence relation on this set S such that this R contains 42 element, and I would say this is the one condition which is making the question itself difficult, right? So when I'm explaining, try to see it very carefully, right? So I'll explain with the help of a small example. Now what small example I will take, everyone? So suppose I have a set A, okay, and which contains just 3 element, okay? And someone will say, can you please tell me how to create the partition on this set, right? How to create the partition of the set, right? So how should I think, everyone, the partition? Now, why I have used the partition? Because you have done in your class that there is a 1-to-1 correspondence between the number of partition and the equivalence relation. There's a 1-to-1 correspondence between the partition and equivalence relation defined on that set, right? So suppose I'm defining one partition of that set. Now what is that one partition? It is 1, 2 union this singleton 3. Suppose I'm defining this partition, right? Please observe this partition well. Now corresponding to this partition, what could be our relation, everyone? So the relation would be using the definition of partition itself. So what could be the relation? 1 should be related to 1, 1 should be related to, so next 2 should be related to 2, 1 should be related to 2, and 2 should be related to 1, right? And corresponding to this, the relation would be 3 cross 3. And why I am giving you this example? Please observe well. If you have the 2 element in this partition, how many element you are getting in the corresponding relation, correct? So there are 4 element. If it is 1, how many? 1, correct? So if it is 3 element, you should understand that how many element it should contain, everyone? 3 square. So using this fact only, we have to solve this question, right? So how should I solve this question? So first try to think, everyone, that this n1 plus, so what I am taking, this n1, n2 represent the number of element present in that partition. So n1 plus n2 plus n3 plus ... this should be equal to 10. But correspondingly, this n1 square plus n2 square plus n3 square plus ... this should be 42, right? Now what should be our next task? I have to think about the non-negative integral solution of these two equations. Now how should I thought about that? Now everyone, how should I thought about that? So in order to think about, now again I am telling, thinking about that is also not an easy task during the exam, right? So how should I think? We need to take the help again, we need to see the second expression, right? Second equation. So if you see the RHS part of that, it contains 42, correct, everyone? Now which square is nearest to that? So you understand the 6 square is nearest to that, right? So how should I break this, everyone? So one possibility, everyone, and how I have started thinking about it, it is 42, correct? Now if it is 42, the square which is nearest to it is what, everyone? So it is 36, 6 square. So I'll start with that. Now 36. Now if I will take that to be 36, everyone, please listen very carefully. Now if I will take that to be 36, the nearest one is 25. Now if I will take 25, you should understand this will exceed. So which we have to make that condition over there. So what should I take next? Now again you can try with 16. Now please check with the 16, again it is exceeding that number. So 16 is also not valid one. Again you should try with 9. So please try with 9, it will be 45, which is not good for us. So again the next one would be what, everyone? So it should be what, everyone? 2 square. Now 2 square is what, everyone? 4. Now 36 plus 4, how much it is? 40. So I'm left with 2 elements and I need to think in terms of square. So how should I think, everyone? This should be 1 and 1. So the sum is 42. Now this is 42 means 6 square plus 2 square plus 1 square plus 1 square is what, everyone? 42. And this will be 6 plus 2 plus 1 plus 1. And what it is, everyone? So it should be what, everyone? 10. Now think this case very properly, right? So we got this case. So first task is to count each of the case, right? So this is my first case. Now what could be the second case? So first think about that case itself. Now what could be my second case, everyone? So we have started with 36. We are done with that. Now we have to start with the next square, which is 25, right? So if I'm starting with 25, 16 would help us because 25 plus 16 is what, everyone? 41, right? So if 25 plus 16 plus 1, everyone, so that is what, everyone? 42. So this should be 5 square plus 4 square plus 1 square. So again, this is 42. So here what it is that part visible, sir? The down part is visible. Okay. Now this part will be what, everyone? 5 plus 4 plus 1 will be what, everyone? 10. Now you can think of another part also, that suppose I will take another to be 16. Now if I will take one to be 16 and another to be what? 9. So we are not able to get our situation. But thinking about that is again not an easy part. So first I am thinking that how I am able to break this, right? So there are two cases I got it, but the question itself is not done yet. You have to think the next part. Now what is the next part, everyone? Now please listen very carefully. You have the 10 different objects and you have to divide it into the groups. Again, please take the help of permutation where you have done division and distribution, right? So what you have the 10 different objects. You need to divide among the 4 groups, right? And what are the group size, everyone? The group size are 6, 2, 1, 1, correct? So if you have this group size, how many such division you will get, everyone? So how many such division you will get, everyone? So for that division, for this, if you see, so the division would be how many division you are going to get? So 10 factorial upon this will be 6 factorial, 2 factorial, 1 factorial, 1 factorial. Now since 1 factorial is appearing twice, you have to divide by 2 factorial, right? So corresponding to this many number of the group you have to form, correct? Now the next part, everyone, corresponding to this, yes. So how many? 10 factorial upon 5 factorial, 4 factorial, 1 factorial. Yes, everyone, correct? So I will do that part. Now I have to find the how many such possibilities, either one case or two case. So I have to add both the cases, right? Now while adding also, just take the LCM first, everyone. So while adding also take the LCM first. So if I will take the LCM, you can see 10 factorial I can take. Because of this 6 factorial and 5 factorial, I can take 5 factorial also common. And this 4 factorial and 2 factorial is there. So I would have taken more. But first I am taking just 10 factorial upon this 5 factorial, everyone. So if I am taking 10 factorial upon 5 factorial, now what I am left with, everyone, over here. So I am left with over here. Now here 1 by 6. Now this is 2 factorial, 2 factorial. 2 factorial is just 2, so that will be just 4. Now plus, everyone. So here also what I am left with. So 1 upon 5 factorial gone, I am left with 4 factorial. And you know that 4 factorial is 24. So this is just 10 into 9 into 8 into 7 into 6. Okay. Now into what it is, everyone? 2 by 24. Now 2 by 24 is just 1 by 12, everyone. Okay. Now you have to just do the normal calculation. So just do the normal calculation. So this will be 2. This is 4. Now 4 into 7 into 9 into 10, that will be your answer, right? So how much it is, everyone? So 4 into 7 is 28. Now 28 into 9 we have to just do, everyone. Okay, so that will be 252. So the final answer is 2520. right? Now when I'm explaining, because I've already solved and then I'm coming over here, so I have the idea in my mind, right? But if you are attempting this question, what you should observe, everyone, that this is the question which you should not attempt in the first go. This is my suggestion as a teacher, right? Choice is yours. Okay, now going back to the next question. So next question, I would say next question is easy or moderate question, because it is coming from the like our notes itself, direct question from the notes, right? So if you look at the first part of this question, they have given the f is defined from minus pi by 2 to pi by 2 to minus infinity to infinity, and f is a good function. Why I will say good function? Because there is the involvement of mod, there is the involvement of x, sin x, greatest and dz, which we do in our usual class also, right? So that's why I will consider this question to be easy moderate question. You should pakka attempt this question. You should for sure attempt this question, right? Now next part, if you see the question, so there are two parts for this. One part, please, you have to find the alpha. What is the alpha, everyone? Total number of points in this interval where this f is not continuous, right? And what is my beta? Beta will be all those points in the interval where f is not differentiable. So I need to find out this alpha plus beta, right? So please look at that question, everyone. So just show me that question once. I'll just write the function and you can. Okay. So what is my function, everyone? So the first part of this function, f is defined from minus pi by 2 to pi by 2 to minus infinity to infinity, and this f of x is this mod of x plus mod of x minus 1 into sin x plus greatest integer of x sin x, right? So first I am thinking about point of discontinuity, right? So my discussion is about continuity only, right? First, so for point of basically discontinuity, how should I think about it? So in order to think about it, first start with the first part of this question. Now what is this first part, everyone? This mod x is always continuous, mod of x minus 1 is always continuous. From the graph you can say, right, everyone? So continuous plus continuous is always continuous, yes? Now here this is what again everyone, sin x. Now sin x is also continuous, so continuous into continuous is continuous, right? But you should recall here itself that continuous into discontinuous is a bad case. Why it is a bad case? Because we can't tell directly that it should be discontinuous, right? You have to check specifically, but in order to check that also there is a theorem which you might have done, right? Now here, so this part continuous, no problem. It will behave very properly, correct? I just need to focus on the second part, right? So I will take that second part as g of x, everyone. So this g of x, and I'll tell one more thing, everyone. If we have a continuous function plus this continuous function, it's a very good case. Why? Because we are pretty sure that answer would be what, everyone? Discontinuous, correct? So since we are pretty sure, so just we need to think about the point of discontinuity for this function. Now try to recall, everyone, when greatest integer function will be discontinuous, wherever, again, this is not fully, like, okay, just listen to my statement. Now what is the statement, everyone? So first, when g of x equal to greatest integer of f of x will be discontinuous, right? So what I am using, the problematic point will be all those points where f of x will be integer, and the problematic point need not to be the point of discontinuity. We need to check specifically, right? So here what is that function, everyone? X sin x. So we can think about this x sin x. Now how should I think? I need to think in this interval. I don't need to go outside of that. They have given minus pi by 2 to pi by 2. Strict yourself in that interval only. Don't think beyond that during exam. After exam, you are very much allowed to think whatever you feel so. Okay, but now please think in this interval only, right? Now if you are thinking, everyone, what you can tell over here, right? Now here, so g of x is this. Now please focus on this. Now please don't get carried away by this. Ma'am is using so many notation over here, f also, g also, h also. No, just for your understanding, just give me a minute over here. Now this is h of x function, so I will ask a simple thing, everyone. if I will find out h of minus x, what I will get everyone? So I will get it equal to h of x. So what does it imply everyone? H is an even function. Now why I am doing so everyone? In order to decide about the graph of this h function, the rough graph. Again I am not interested in the full graph. I am just interested in the rough graph of this h function, correct? So we have got h is an even function, and if I will find out this h of 0, that is also what everyone? 0 itself, correct? Now if I will find out h of pi by 2, okay, now if I will find out h of pi by 2 everyone, it is also pi by 2 and this function is continuous, so we can think of the graph over there, right? Now how we can think of the graph everyone? Or moreover, now if you want to do some more analysis over there, what you can find out? You can find out the derivative of this h function. So if I will find out the derivative everyone, so this is h dash x everyone, right? Now this is x into sin x everyone. So what should I do here everyone? Now this, keeping this sin x constant. Now okay, so first what I will do, keeping this x constant, what is the derivative of sin x? So x cos x, correct? And keeping this sin x constant, what is the derivative of this? Now please focus on this derivative everyone, because my concerned interval is everyone minus pi by 2 to pi by 2. No, I am just seeing over here, since it is an even function, so my concerned interval, again I am repeating, is 0 to pi by 2. My concerned interval is 0 to pi by 2, correct? Now if I am seeing that part everyone, so in this interval, this h dash x should be greater than 0, so which is clearly suggesting that h is increasing in 0 to pi by 2. Correct everyone? Now if h is increasing in 0 to pi by 2, so if I will draw the probable graph, again I am telling this is not the exact graph. For exact graph, you have to check the concavity also over here. But we are not checking, not required in the question. So don't do PhD over here, right? So just 0, this over here. Now at pi by 2, answer is what everyone? Pi by 2. But we don't need to think about that also. Suppose my graph is somewhat looking like this, somewhat. Is it fine everyone? So if my graph is looking like this, since it is an even function, so it has to go like this only. Okay. You have to draw the correct graph. This is the probable graph. You have to go with that only. Okay. Now what you have to think, see everyone. So this is pi by 2. So 0 to pi by 2, 1.57. What is the integer it is taking? So it is taking the integer as at 1. Okay. So I am telling this point to be somewhat gamma. For example, okay. Now please observe the graph between 0 to gamma. This graph is lying between where to where everyone? 0 to 1. So what is its greatest integer everyone? 0. So this part will come over here at gamma everyone. Answer is 1. Okay. At gamma answer is 1. So you are able to see one point of discontinuity over here. Now between gamma to this pi by 2. What is my graph everyone? So my graph is lying between where to where everyone? 1 to pi by 2, correct? Now if it is lying between 1 to pi by 2, what is its greatest integer everyone? So the greatest integer is 1. So this is my graph this side. The same graph it will repeat. Okay. So even if you want to see over here, so try to observe. So if this is gamma, using symmetry, it has to be minus gamma everyone. And if I am seeing my graph from minus pi by 2 to minus gamma, correct? Minus pi by 2 to minus gamma, right? So if you observe this graph everyone between this part, so graph is lying between 1 to pi by 2. So again greatest integer part will be what everyone? Just 1. So this part, correct? Now if you're seeing it from minus gamma to 0, if you're going from minus gamma to 0, what you can observe that your graph is lying between this 0 to 1. So the greatest integer would be everyone, this 0. So if you observe how many point of discontinuity everyone, there are 2 point of discontinuity. So please keep that fact in your mind. So how many point of discontinuity I got? 2 point of discontinuity. So what is my alpha everyone? So we got alpha as 2. Now we have to think about the number of point of non-differentiability. So how should I think about the number of point of non-differentiability everyone? Correct? So this is the part. Please keep that part in your mind. Why I am telling you keep that part in your mind? Because you know that if a function is not continuous at a specific point, it should not be differentiable at that point. So these 2 points, gamma and minus gamma, will act as point of non-differentiability also, right? What more point everyone we need to think, correct? So what more point? So we have the probable graph. So from the graph itself, for greatest integer of x sin x, these 2 points are acting as our point of non-differentiability also. Correct everyone? Now we need to see the other part. Now since the other part contains mod everyone, right? So what you have studied in your class, right? That this mod function, mod of x is not differentiable at x equal to 0. Why? Because there is a sharp edge, there is a corner point over there, right? So how should I think about that everyone? So in order to think about this part, I will write this as mod of x into sine x, okay? Now this mod of x minus 1 into sine x, right? Now plus greatest integer of x into sine x. Yes everyone, correct? So if I am writing like this, what should be the next part everyone? Please listen very carefully, right? So now what do you know that? Now here, this part we got non-differentiable at gamma and minus gamma, correct? Now we have to see this part, correct? So first I am seeing this part. Please observe well that x equal to 0 is the point of non-differentiability, correct? But you have done one theorem. Now what one theorem everyone? Please try to recall. If you have the two function, the product of two function everyone, take. Now this g function is differentiable everywhere, but f is not differentiable at x equal to alpha, correct everyone? But this g of alpha is becoming 0, then overall product function should be what everyone? Differentiable. If g of alpha is not 0, then the product function won't be differentiable. I'm going to use that fact over here, correct everyone? Take. So if I will mod of x, so what is that point? Problematic point, x equal to 0, but at 0, the sine 0 is giving what everyone? 0. Is it fine everyone? Correct. Now the next part everyone, please see very carefully. The problematic point is x equal to 1 and at that this is giving sine 1. Okay. So at x equal to 0 function is differentiable. Yes. But at x equal to 1 function is not differentiable. At x equal to 1 the function is not differentiable. So how many points of non-differentiability everyone? So previously the gamma and minus gamma, we don't need to do PhD in trying to find out what is that gamma and minus gamma. You can do afterwards, right? Here what we should understand that gamma can't be that 1 also. That you can check. That gamma can't be 1 also, right? So here how many point of discontinuity everyone? 2. So my alpha is 2. How many point of non-differentiability everyone? This 2 plus 1 which is 3. So if I am not wrong, they have asked what is alpha plus beta, so that is 5. You got this answer. Okay. Now moving forward to the next question everyone. Okay. Now again I will consider this question as a good question. Whenever permutation combination question is being asked, you have to be extra cautious. Why? Because the name itself is permutation combination. You have to think deeply over there. Whenever you are doing counting, even if you miss one case, your answer would be wrong only, right? So you have to think very properly. But this question again, this is not a very tough question of permutation combination, but they are framed in a way that you may get confused, right? So what you have to think about it everyone? Take. Again I have to see that question, sir. Okay. Now the question itself, what it is saying that the number of ways, please see, the number of ways to distribute 10 identical objects. First, please focus on identical term. Take. Now this identical object itself will tell you that either you have to take the help of Quines and Beggar's method or multinomial theorem. This identical object, distribution of identical object, Quines and Beggar or multinomial theorem. Correct everyone? Right. 10 identical red pens and 14 identical blue pen. Among how many person everyone? 4 person, such that each person should get 6 pen. Okay. So this is the question which they are asking everyone. So try to see that part. Okay. Now here just one important thing. Now what is that important thing everyone? So first try to think that you have the 10 identical red pens, okay, and you have 14 identical blue pen. Okay. Now everyone, please try to understand the first part of it. 10 identical red pen. Correct everyone? Right. So how should I think about 10 identical red pen? Okay. So now first thing, suppose I am telling R1 is the number of red pen that a person gets. R2, the number of red pen that the second person gets, right? Now R3, number of red pen that the third person gets, and R4, number of red pen that 4 person get, right? And you know that over here that this, now everyone, so what do you know over here, that this R1 plus R2 plus R3 plus R4 should be what everyone, 10, and this B1 plus B2 plus B3 plus B4 has to be 14. Okay. Now what is the one thing? Now one thing that each person should get how many object everyone? 6 object, right? And if you add this 10 plus 14 is what? 24, right? So here what we can observe the next part, that each of the Ri plus Bi has to be what everyone? 6, right? So if each of the Ri and Bi has to be 6, so whatever the distribution you are thinking over here, accordingly this distribution will be taken care. For example, try to think, suppose I am giving this R1 5 object. Okay everyone, if I am giving R1 to 5 object and this R2 for example I am giving 4 object, take, right? And R3 I am giving 1 and this 0. Take. Now what you can observe over here, and left with 14 object. So how many more blue pen I should give to this first person everyone? So this is P1, P2, P3 and P4. So accordingly this, how many everyone? 1. How many this everyone? 2. How many this everyone? If you see the P3, so P3 has to go 5 object, and here how many everyone? 6. And if you add them, it will be 14 only, right? So rather than, now this is the key point over here. So what you have to think, I just need to distribute this identical red balls and we are done with the question. But we are not distributing just randomly. Why so? Because this Ri plus Bi equal to what everyone? 6. And this will give what everyone? If you see, so this Ri should be equal to this 6 minus Bi everyone, and this Ri should be what everyone? Greater than equal to 0, correct? And under this restriction, what you can observe also that this Ri should be less than equal to 6, correct? So what is my question everyone? Now please listen very carefully. So I need to, the first thing, this I have to find out number of non-negative integral solution of this equation, correct? Number of non-negative integral solution of this equation everyone, under what restriction everyone? So this Ri should be less than equal to 6. Okay. Now the first part what I am doing over here, so I am finding total number of ways without any restriction. Please try to recall the coins and beggar method everyone, right? Now what coins and beggars method tells you, that you have the 10 identical object, you need to distribute among 4 person. There is no restriction on the number of object that a person gets, but all objects should be distributed. You have to distribute 10 identical object among 4 person everyone, right? Such that no restriction on the number of object that a person gets, but all objects should be distributed. So here total number of ways without any restriction. So total number of ways without any restriction. So what I will get over here, total number of ways. So n plus r minus 1, c r minus 1, n plus. So this will be 10 plus r minus 1, r this, c 4 minus 1. Is it fine everyone? So this what we have got without any restriction. So if we have got so this will be equal to what everyone? So 14 minus 1. So that will be 13 C3. This is what we have got. Now we need to think about what is the restriction. So here we have not thought that this Ri, each of Ri should be less than equal to 6. That we have not thought, right? So now how we are going to think about it? So now please listen very carefully. So here in this case what we will do, now we have to think about the unwanted case. So in one unwanted case, the one case would be in unwanted case there should be one case where this P1 gets at least 7, the first person P1 gets at least 7 objects. Okay? Now if P1 gets at least 7 objects, now R1 plus R2 plus R3 plus R4 equal to 10. So this R1 is already what everyone? greater than equal to 7. So first what I should do, everyone, please recall the coins and beggars method. Now here what you should do, out of 10 objects, please pick 7 objects and give this 7 object to P1 and tell that you should be happy. You got 7 objects now. That is what you want. Just take 7 objects and go home happy. Okay. Now this is not, don't tell that go home, because that is not allowed also over here. That you have given 7 objects and tell him that you should be happy, but here something more is left. Now what something more, everyone? Take. Now if I have given 10 objects, sorry, out of 10, if I have given 7 objects, how many objects I am left with, everyone? 3. But this 3 identical objects, again I have to distribute among how many person, everyone? 4 person. Right? So how many ways do we have? How many ways do we have, everyone? So again, so this will be n plus r minus 1 c r minus 1. Okay. So this will be 6c3. Right? Now, please try to understand. This is the case where I have taken that P1 should get at least 7 objects. There could be the case where P2 is getting at least 7 objects. Similarly, P3 is getting at least 7 objects. P4 is getting at least 7 objects, right? So what should I do, everyone? But each of the cases would be same only, right? So here 6c3. So I can find out this number over here, or 13c3. I should find that also. Otherwise, you will feel key. Now this is 13c3. So 13c3, how should I calculate? 13 into 12 into 11 divided by 3 into 2. So this will be what, everyone? 2. So if I will do 22. So this will be 13c3. 13 into 12 into 11 divided by 6. 3 into 2. Yes, everyone. So this 2. So what I am left with? 22 into 11, everyone. If I am not wrong. So 22 into 11. Sorry. No, my bad. So this 11 into 2 is what, everyone? 22. Now 22 into 13, everyone. So this will be how much, everyone? 286, everyone. Correct? Now here this is 286 and this number also we can calculate easily. So this will be what, everyone? 6 into 5 into 4 divided by 3 into 2. So this gone and this is 20. But I have already told you, the same case occurs with all the 4 person. So how many unwanted cases, everyone? 4 into, so I should write over here, everyone. So total number of wanted case, wanted. So total number of wanted cases will be this. Total number of ways without any restriction minus total number of unwanted ways. Total number of unwanted ways. Okay. Now if you see it over here, total number of unwanted ways. So this unwanted. So total number of ways 286 minus this 4 into 20, which is what, everyone? 286 minus 80. So this I am left with 206. Is it fine, everyone? So 206 should be the correct answer for this question. Now moving forward to the next question, everyone. Yeah. So this is a trigonometry question from your favorite topic, which you have done which you have done in the first year. So your favorite topic, I would say. Now here what you have to observe here, that this is 1 minus 2 cos theta into, okay, 1 minus 2 cos pi by 11 into 1 minus 2 cos 3 pi by 11 into 1 minus 2 cos 9 pi by 11. Now dot dot dot, not dot dot dot, till 81 pi by 11, correct? So what you can observe, whenever something is given in the product or whenever something is given in the sum, what you have to observe, everyone, that you have to convert it into telescopic somehow. Need question. I need, okay. So here what we should observe, that again we have to convert it into telescopic, right? But how should I convert? So before converting that, again I will ask about the question, but first time I have to say something more. Take. Now you are observing something over here, 1 minus 2 cos pi by 11, right? So first thing what I will do, I'll take theta to be pi by 11, okay? Okay. So please try to see what I am trying to establish over here. Just one small result. So here what I have taken this theta to be pi by 11. Okay. So if I have taken theta to be pi by 11, I just need to establish a simple result. Now what simple result, everyone? So this will be 1 plus 2 cos 2 theta. If I will ask, take. Now why I am asking, will understand in a minute over here, correct? So 1 plus 2 cos 2 theta, correct? So now this 2 cos 2 theta, can I convert it into terms? Now you may ask, ki ma'am, in question it is 1 minus, but you are doing this, it is not at all acceptable. I'll explain why it is not at all acceptable just after a minute, okay? Now, why it is at all very much acceptable. Now you will feel why I am starting with this plus part, correct? Now 1 plus 2 cos 2 theta, everyone. So this cos 2 theta, how should I write, everyone? 1 minus 2 sine square theta. Now this will be what, everyone? 1 plus 2 minus 4 sine square theta. Now this will be what, everyone? 3 minus 4 sine square theta. Now looking at this, you should be very happy. Why you should be very happy, everyone? Because this formula you have done already. Not this 3 minus 4 sine square theta, but you have done something more. What is that something more? 3 sine theta minus 4 sine cube theta. So if I multiply by sine, again this is a very good expression, right? So now I will explain why I have not started with 1 minus 2 cos 2 theta. If you see 1 minus 2 cos 2 theta over here, and I will do the same thing over here. So this will be 1 minus 2 sine square theta, everyone, correct? So what I am going to get over here, 1 minus 2, now this will be what, everyone? 4 sine square theta. So this is not a very great expression which I am getting. Did you get my point? So just working with this is not a great idea, but working with this is a great idea, correct, everyone? So we have started with that. Now what we have observed, everyone, over here, so here, so if I multiply the given expression, so you got the idea this. Now I am multiplying the given expression by sine theta. I am multiplying the given expression by sine theta, sine theta, sine theta. Now sine theta, everyone. So if I am multiplying by sine theta, what you can observe over here, correct? So now this will become 3 sine theta minus 4 sine cube theta. So 34, if you are able to recall, 3, 4, 34. Now in this way only you have remembered sine 3 theta formula. So this will be what, everyone? Sine 3 theta over here, correct? So we got sine 3 theta basically. Now if you have observed, so this what we have got, if you have observed, so we got sine 3 theta upon sine theta as 1 plus 2 cos theta. Have you observed that? Now if you have observed, now it is good for us. Now this is sine 3 theta upon this sine theta, everyone. So this will become 1 plus 2 cos theta. But again your question will remain same, right, everyone? So again my bad. Sorry about that. It's not theta, it's 2 theta. Try to see. It's theta, here it's 2 theta. So use that, okay? So if I will use over here. Now again you will tell ki ma'am, it's not working very much. I'll say yes, it's not working very much. So first replacement, what you have to do, please replace this theta by 2. Same formula I will get. Now this will be sine 3 theta by 2 and this will be what, everyone? Sine theta by 2. Similarly I can prove for that part, correct? So if I am doing so, this will become just 1 plus 2 cos theta. Again you won't be very happy, because there is a minus. So how should I create the minus, everyone? So cos theta we don't like, plus over here I want minus. So how should I get that? We have done so many things in the allied angle chapter. So how should I convert, everyone? So I have to replace this cos theta by cos of pi minus theta. So if I will do so, everyone, this theta, if I replace this pi minus theta. So try to be with me and help me. So if I will replace, everyone, what I am going to get, so please help me with that. So this will be what, everyone? 3 pi minus theta whole divided by 2. So this will be 3 pi by 2 minus theta by 2. And this sine theta by 2. Again, what I will get, everyone? Pi by 2 minus theta by 2. Am I writing correctly, everyone? Now you know what is sine 3 pi by 2 minus theta by 2? Minus of cos theta by 2. Okay. I did a mistake over here. Now 3 pi by 2 minus 3 theta by 2. So this would be cos of 3 theta by 2. Now here, this should be what, everyone? Cos of theta by 2, right? So what we have got over here, this expression like this, minus. So what we have got, everyone, again please try to observe. Now this is the thing which we are going to use in for our question. Okay, so here if I have used, so what it has become, everyone, if you observe, so this part is visible over there, this part. Okay, now this part, so 1, I can also see. Now 1 minus 2 cos theta, everyone. So what basically we have got over here, I got minus of cos 3 theta by 2 divided by cos of 3 theta by 2, and we have to use this only. Now please come back to your question and try to see what is given over there, right? So again, can I see the question? Okay. Now just everyone, so what is my alpha? So this will be in terms of theta. Please help me with that. So this will be what? 1 minus 2 cos 1 minus. So I will erase this part and I will just do it over here itself. But I'll keep that fact over there because we have to keep referring that part. Okay. So we have whatever we have got, that is a final one which we have got. We'll keep using that. So first I'm writing in terms of theta over here. Correct? So what is that we have got, everyone? So please try to see in terms of theta. I know you won't like it much, but please. 1 minus 2 cos theta. This is the first part, and I've already told you my theta is pi by 11. So let theta is pi by 11. Correct, everyone? Now if you see the next part, again I want to see the question once. I'll just copy in a minute and I'll get back. Now 1 minus 2 cos, this should be what, everyone? 3 pi. So this will be what, everyone? 3 theta. 1 minus 2 cos, the next one has to be 9 theta. And 1 minus 2 cos, the next one has to be 27 theta. 27 theta. Now the next part, 1 minus 2, and this all are theta, don't consider it to be 0, please. Now 1 minus 2 cos, that is 81 theta. Okay, everyone? Now you can. Okay, now everyone please. So using that 1 minus 2 cos theta, please use that. So now how many bracket do we have? 1, 2, 3, 4, 5. So 5 brackets. So this minus sign will carry. So this minus, so I will get for sure. Now after that, what I am getting, everyone? So for this part, what I am getting? Cos of 3 theta by 2 divided by cos of theta by 2. Now next component. If it is theta, here I am getting 3 theta by 2 and theta by 2. So if it is 3 theta, everyone, so what I will get, everyone? So I will get cos of 9 theta by 2 divided by cos of 3 theta by 2. The next one, if you observe, everyone. So the next one, what I am going to get? So if it is theta, I got 3 theta by 2. So if it is 9 theta, what I should get, everyone? 27 theta by 2 and divided by this cos of 9 theta by 2. And the next one, again, everyone, I should not write, but again I'm writing. Okay. Now this will be what, everyone? Cos of 81 theta by 2 divided by this cos of 27 theta by 2. Now into the last part, everyone. The last part is important, which we should write. Okay. So what is the last part I am getting, everyone? Cos of 243 theta by 2 divided by, everyone, cos of 81 theta by 2. Are you able to observe, everyone? Correct? And again, now you will feel very, very happy looking at this because intermediate terms are getting cancelled. So I'm just left with a few terms, right? Now what are the few terms? Minus of cos 243 theta by 2 divided by cos of theta by 2. Correct, everyone? Now cos of 243 theta by 2 divided by cos of theta by 2. Okay. Now there is the role of this theta over here. Now what should I do, everyone? I have to just simplify it. Now how should I simplify, everyone? Try to see that. So this is what, everyone? Cos of 243 into this pi by 11. So this will become pi by 22. Correct, everyone? Now how should I do that? Please divide it by that. And if I am not wrong, what I am going to get? So if I will divide. So this will be 1. If I divide 243 by this 22. So this will be, 11. So what we have got, everyone, over here. So this 243. How should I write, everyone? So this 243 I can write over here as 11 into 22 everyone. So this will become now plus 1 only. Correct everyone? So if I will do that calculation, the small calculation, just give me a second. Yeah, correct. Yes everyone. So how should I write that? So this will become 11 into this 22, 11 into 22 plus this 1. So this is basically becoming, if you see it, 11 pi plus 11 pi plus this will become pi by 22. Correct everyone? Now this is cos of 11 pi plus. So this will be what everyone? Cos of pi plus 10 pi plus. So 10 pi plus what it will give everyone? So 10 pi plus this. So 10 pi plus positive 4, sorry, the first quadrant everyone. So just I am left with what everyone? Cos of pi. So this will be minus of cos of pi by 22 everyone. So this will become everyone. So this I have already explained. So this will become what everyone? Minus of cos pi by 22 everyone divided by, this will be cos of pi by 22. This getting cancelled. This is 1. So my alpha is what everyone? 1. But the final answer, I am not interested in alpha. I am interested in 5 minus alpha square, which is 5 minus 1 square, which is what? 4. So I am interested in, I will write it over here everyone. So I am interested. Now again in exam, during exam you will be in hurry and you will mark 1 as the answer, and that is wrong. And again you will feel very bad after coming home. I have put so much effort over there and then again I am marking the answer to be wrong. Correct everyone? So what you should do, read the question very properly. That is the first instruction which everyone used to give it to you, right everyone? So what is the next part everyone? So this 5 minus alpha square, so this will be 5 minus 1 square, so it will be what everyone? 4. So thank you so much. I hope that you got all the four solution very properly. If not, again you can go back and you can keep seeing, and I would say that please see the 9th question very properly, because it is one of the toughest question which they have asked in the paper 1 of, because that is JEE advanced exam will keep seeing the toughest question only. Okay, bye bye and thank you so much.